Okay, come. Today let's go to 8.10. 8.10. I think you're all using third edition book, right? I think it's page 190. Ryan, I know you've done the question before, but I will just go through again this topic, and I want you to try the questions today. But let's just go through again. Okay, so you can see my screen, right? Series and parallel circuit. So this one, we went through before, very briefly. We'll just go through again, so that at least you can prepare to do the questions in topic 8.10. Okay, so so remember when we talk about series and parallel circuits, excuse me. So for series circuit, we are referring to, of course, the components, like the light bulb. When you arrange in series, means all in the same line. Where's my mouse? Mouse. They're all in the same line, like that. So that means they're one after the other. Parallel is when the components are arranged in different lines. That means like this is split into two lines. So when we compare current, remember for series circuit, the current from beginning to end is all the same current. You think of it like water flowing like that. Same. But for parallel circuit, the current, right, flow. When it come here, A got two branch, it's split, and then A join back together. That's why when I put like this, I equals I1 plus I2. I is the current coming up from the dry cell, also the current that go back to the dry cell. But I1, I2 is the separate line. So remember, it's split. So that's why it's like, you see, mathematically, it should make sense. I is I1 plus I2. Potential difference, on the other hand, is based on 2 points in the circuit. So like we see V1 is here, V2 is here, they are separate position. So V1 and V2 not necessarily the same. They're not the same. But V, you see V, start from, you imagine the current, you imagine the current flowing this way. From the dry cell, from V, current is flowing. Let me just use my laser pointer. Right, it's flowing, right? So you can see how this point is like include these points and then these points and goes back. So it's like inclusive like that. Something's wrong with my connection, my mouse not smooth. So that's why V is V1 plus V2. But for parallel circuit, if you try to apply the same concept, the problem is because the current split into two. So when we look at how the circuit is, we only look at one line at a time. You cannot like, okay, backtrack, you cannot do that. So it's like, okay, current flow, ignore one line, take the other line, you see, this V, there's nothing else here, is including V1. Then you put one side, try again, V also equal to V2. That's why V is equal to V1, V also equals to V2. That's why for parallel, V equals to V1 equals to V2. Whereas for resistance, when you count effective resistance, series is very straightforward. You just plus together only. Parallel circuit, you calculate using 1 over R. Okay. So just to remind you, right? My tablet not plugged in. So just to remind you that, okay, when you calculate, or when you don't calculate, when you want to solve questions involving parallel or series circuits, right? So for this particular topic, you need to use the formulas V equals IR a lot. And then when you want to calculate, let's say it's a series circuit. Okay, let's say it's a series circuit. So when you want to count V equals IR, you think of it this way. Like when you're counting V, let's say you're counting V for this one, I put V1 now. Okay, let's say the voltage here is given 6 volts. 6 volts, V1 and 6 volts is not the same. V1 is not 6 volts. So you remember that when you count V1, V1 is only for this resistor. Let's say this resistor is 2 ohm. Let's say this resistor is 4 ohm, let's say. So let's say the question could be something like, okay, find out what's V1. So you can see here, hey, V1 is not 6 volts. Then how to count V1? V1 is only for the 2 ohm resistor. Then if you look at like, hey, how to count? Then we try to recall back the series table, because why we learn this is important so that we will know how to solve questions like this. So my question here is, what is V1? How much is V1? Okay, let me put it this way. Calculate the value of V1. Okay, so this one is this is not like the one in your book, but you need to learn to count, because in IGCSE, so they will ask you to figure out. So let's say you look at this, how to count. Then you need to recall that the current is the same throughout. So we now know, the current is the same, current is the same. Why is this important? How does this help us? Because we have V. So when you use this formula, you must think of it this way. V equals IR. You take, first of all, you can consider, okay, let's look at it from the overall perspective. Overall means a whole circuit. Whole circuit, V is 6 volts. And I, we don't know. But R, you see a total R, this is series of 2 plus 4. You get 6 ohm. Okay. So how is this going to help us? Because then we look only at the 2 ohm resistor. That means now you look only this section here, So now V1, we don't know how much. Current also, we don't know how much, but we know the R is 2 ohm. Now, the relationship here is this. This I and this I are the same. So how to solve? We find out this I first. That's why from here, overall, 6 volts overall resistance, overall current. So when you count, you can get the current. So the overall current is 1 ampere. And this overall current is same as V1. That means you can take back this I and put inside here. So you want to find V1, you take the I, you substitute inside here. Then you can get 2 volts. Clear? I think you learned this before, right? Yes? I should check. Sorry, I know, Ryan, you sent to me before. I haven't. I only marked 8.0, I didn't mark 8.10. I'll check later. So can you understand this working? Think so? Okay. This one need to try lah. That's why I also want you to try these questions, but I want to explain roughly like this kind of questions. Let's try, let me show you one more example. Now this one was series circuit. Now let's try parallel. What kind of question they can come up with? Or how to solve lah. Like sometimes the question can change, right? Obviously, like they can change what question. Maybe they ask you for V, maybe they ask you for I, maybe they ask you for R. They can ask you different kind of question. Important thing is you must know how to make use of your knowledge to solve the question, to solve the problem. Let's say now this is parallel circuit. Later, I just want to show you some examples of parallel circuits because you need to get used to the different kind of parallel diagrams also. After this slide. Let's say now this is 6 volts. Let's say now I put the 2 ohm and 4 ohm resistor like this. And then the question could be something like this. You know, they ask us to find out let's say this is A1. Let's say this is A2. Let's say this is A3. Example example. So the question could be something like determine the emitter readings of A1, A2, and A3. how to solve. Okay, so how to solve? Again, let's recall what we know. So we know that the current flowing out here was split into two, say I1 and I2, and then join back together become I. Okay, so that means if we can find A1 and A2, you can find A3. How to find A1? Now, as long as got nothing else in the circuit, you see A here blank, only resistor here, here blank again. Then you remember, oh, parallel V is the same. So for parallel circuits, V same. That means now if I put a voltmeter here, V1, actually, and I put another one lah, here is here V2. Hey, all same, that means V1 x V2 equals to 6 volts. So when you want to account for A1, then you remember, you only look at that section. V1 is only here. So V1 equals to IR. We know V1 is 6. I1, this I1 lah, I1 lah, okay? I1, R1, okay? So I1 don't know, but R we know is 2. So you can calculate, oh, I1 is 3 ampere. Then when you calculate for this one, let's say V2, I2, R2. So V2 is 6 because I write here so that we can refer, oh, V2 is 6. Okay, 6. So I2, oh, we don't know. R2 is 4. You only look at that section, you don't kepo other section, you know. You see, hey, this one is for here only, you count only for this one. You count, you will get 1.5 ampere. That means what? That means A1 reading is 3 ampere, A2 reading is 1.5 ampere. Then from here you can see, hey, this one we learn I1 plus I2 become I. That means A3, you plus together, 3 plus 1.5, you can get 4.5 ampere. Can follow? Yes, okay, good. I'll throw in one more question. I'm sure you've done before, but I'll just show you anyway. Let's say they ask you to calculate the effective resistance of the circuit. Let's say lah. So when you calculate the effective resistance, now because this is parallel circuit, parallel series very straightforward, you just plus together, but this is parallel. Then your book got say resistance multiplied divided by resistance added. You can use that, but personally for me, I find too many things to memorize. So I like to use 1 over R method, but you must be careful with this lah. Meaning when you use 1 over R, right, you must remember it's 1 over R1 plus 1 over R2. So when you solve this, you count like this. You count first how many lines, how many branches? 2 branches, right? 2 branches means must have 2 fractions. This line is 1 line. The number 2, you put under the first 1 over 2. This is the 4, you put 1 over 4. Now, then you solve this one. 1 over 2 plus 1 over 4 is 3 over 4. But you must remember this 1 over R. So then you must flip. So that means it becomes R equals to 4 over 3 equals to 1.33 ohm. Don't make the mistake. I got some students, 1 over 2 plus 1 over 4, or 1 plus 1 is 1, 2 plus 4 is 6, 1 over 6. Happened before, okay? So, don't you solve everything like normal first. Get this answer side by side. You see, oh, 1 over R is 4 over 3. Flip. That's how you can get the answer. Can? Any questions? Okay, so we stop now. All right, bye.